Hi guys, welcome to my YouTube channel, Ep1 here. Today I would like to share with you a topic of velocity and acceleration in mechanics. In the diagram on the screen, you can see that there are two different terms, distance and displacement. Both of them describe how far away of two objects. In daily life, we walk along this distance to our destinations. But in the mindset of physics, displacement refers to the shortest path between two objects. In physics or in mechanics, in this course, we use displacement from time to time. The next diagram tells you the same thing. Okay, in this diagram, the total distance traveled is the sum of 4 meters and 3 meters, that is 7 meters. However, displacement refers to the shortest path, so the displacement is 5 meters. Please notice that a distance has no directions, so we don't have negative distance. So let's say that you have traveled negative 3 km. Okay, there's no such thing. We call this kind of quantity without directions as scalar. On the contrary, displacement has directions. We call this kind of quantity as vector. In this diagram, the distance traveled is the sum of 2 up and 3. We go to the right hand side for 2 blocks and then move to the left hand side for 3 blocks. So the total distance is 5 blocks. However, displacement refers to the shortest path, so the displacement is negative 1 block. So please pay attention that the negativity means the left hand side. Left hand side is negative and right hand side is positive. In this diagram, you can see the difference between speed and velocity. Although they mean the same thing, they mean how fast the car is traveling. But speed, you can see that for speed to the right hand side, if it goes to the right hand side, is positive 25 meters per second. If the car travels to left hand side, the same. Okay, because speed is a scalar, it has no direction, so there is no negative speed. However, for velocity, right hand side is positive. That's why at positive 25. For if the car goes to left hand side, it is negative 25. Okay, let's see this triangle. This triangle is very useful one. Usually when I teach junior form students, I use this triangle to help them to remember the formulas of 3 formulas actually. Okay, if we need to find speed, okay, very easy. You just put distance over time. If you are required to find time, okay, so divide distance by speed. In some case, we need to find distance. Okay, very easy. We just time speed by times. Okay, so for diagram, a triangle with just 3 letters in the middle, it helps you to remember 3 formulas. Okay, in the context of mechanics, we from time to time use velocity instead of speed and displacement instead of distance. But it doesn't matter, you can still use this triangle to set up equations. Okay, let's see an example. You drive to a store and return home in half an hour. If your car's odometer shows the total distance traveled was 6 km, determine the average speed and velocity. Okay, for average speed, if we need to find speed, okay, just distance over time. So distance travel is 6 km. Time is half an hour, so we change to 0.5 hours. So the answer is 12 km per hour. In part B, we are required to find average velocity. In the numerator, we need to put the total displacement. Now go back to see the question. We start from home, go to store, and then go back. Okay, in this case, the displacement is 0. Okay, although you have traveled somewhere and back, but displacement just talk about the distance between the starting point and the end point. So the displacement is 0. So we don't need to calculate anything. Okay, let's see one more example about speed and velocity. This question says the distance between A and B is 5 km. Paul went from A to B with average speed 12 km per hour and returned to A in this speed 10 km per hour. Okay, so in part A, we are required to find the average speed in the whole journey. In part B, we separate into in part B, we are required to find velocity, the first thing, and then we separate in two legs from A to B and from B to A, and part C find the average velocity for the whole journey. To find the average speed, we need to put the distance on the top, in the denominator the time taken. Okay, the total distance, because we go back and forth 5 km, so the total distance is just 10 km. Okay, total time taken is 5 over 12. Now how come the 5 over 12? Okay, dst. Okay, this time we need to find time, so distance over speed. So 5 km over 12. 12 is speed for the first leg, and then when Paul went back from B to A, is 5 km over, the speed changed to 10. So I use the calculator to find the total time taken is 0.917 hours. Okay, so average speed is 10 over 0.917. So we have this average speed. Okay, in part B, we are required to find average velocity. Because velocity has direction, so we need to decide the sign of the quantity on these quantities. So perhaps this way we call it positive. So from A to B is positive 12 km per hour. When he ran back is negative 10 km per hour. Okay, in the whole journey, for the whole journey, he went back and forth. So the starting point and the finish point is the same. So in this case, the displacement is 0. So 0 over time. So of course the answer is 0. In these two examples, we have learned the difference between speed and velocity. Sometimes velocity is quite difficult to comprehend. For example, in B3, the average velocity in the whole journey is 0, but we have gone somewhere and back home. But the deflation of displacement measure the distance between the starting point and the end points. So the answer is 0. Okay. Anyway, we move on to next topics. The next topic we are going to learn is accelerations. If we travel in a car, it speeds up, it accelerates. It slows down, it decelerates. Please notice that acceleration is a vector quantity. It is a direction. It has positive acceleration and negative accelerations. The formula for accelerations is change of velocity over change of time. Okay, you can see that delta V and delta T. Delta usually refers to change. Okay, so change of velocity over change of time. Okay, the unit for acceleration is meter per second square. Okay, and the sign of acceleration depends on the numerator, delta V. If delta V is negative, and then it is a negative acceleration. Negative acceleration is actually a deceleration. Okay, let's see an examples of acceleration and decelerations. Okay, in the diagram, in case A, the car is going to the right hand side and speeding up. So velocity and velocity, both of them are positive. Generally speaking, they have the same sign. Okay, in part B, in case B, the car goes to the right hand side, but is slowing down, so it decelerates. In this case, velocity is positive because it is go to the right hand side, but acceleration is negative. In case C, the car goes to the left hand side, so V is less than 0. V less than 0 for both case C and case D. In case D, the car is speeding up, okay, because we keep the same sign of velocity and accelerations, so A is less than 0. Okay, it decelerates, slowing down, so it decelerates the opposite side of velocity, so A is bigger than 0. Okay, in summary, in these 4 cases, we know that the velocity is positive or negative depends on the directions. If it goes to the right hand side, positive, left hand side, negative, and accelerations is the same or the velocity. Okay, so for this example, okay, go to the right hand side and accelerate, A is bigger than 0. For this case, and go to the left hand side and accelerate, so they have the same sign. Okay, in these examples, a racehorse coming out of the gate accelerates from rest to velocity of 15 meters per second, due rest in 1.8 seconds. Okay, right down here, start from 0, okay, start from rest to 15 minutes per second, because it goes to rest. Okay, so we put a minus sign before that, and the time used is 1.8 seconds. Okay, the question requires us to find the average accelerations. Okay, the formula for average accelerations is change of velocity. The change of velocities, so the new one is negative 15, the old one is 0, so negative 15 minus 0, the time used is 1.8, so the answer is negative 8.33. The unit is in meter per second square. We'll check one more thing in these examples. In this example, velocity is negative 15 meter per second, and the acceleration, okay, the horse from rest to 15 meters per second, so it accelerates. Okay, but the sign is negative 8.33 meter per second square. In the last diagram, we said that velocity and acceleration are always has the same sign. Okay, so these examples tell us the same thing. They have the same signs. Okay, let's make clear about the sign of velocity and accelerations. For this one, he starts to run, so the final velocity is bigger than 0. Okay, and then because at the beginning of the race he accelerates, so acceleration is bigger than 0. Okay, in the second diagram, he's still running, okay, but he run slow down, so in this case velocity is bigger than 0. Okay, but because he slowed down, so acceleration is less than 0. Okay, let's look at the last example. A train accelerates from rest to 30 km per hour in the first 20 seconds of its motions. After that, it keeps in constant speed for 20 seconds. Okay, finally, the train use another 8 seconds to stop. Okay, basically, the train accelerates and keep the same speed and slow down. Okay, in part A, what is the average acceleration while speeding up? Okay, so the numerator is 30 minus 0. Okay, because the train accelerates from rest is 0 to 30, 30 minus 0. Okay, but need to time 1000. Why? Because 1 km is equal to 1000 meter. Okay, we need to change to the unit to meter, so we time 1000. But how comes the 3600? The units or speed is in hour, but you can see that the answer in seconds square. Okay, so 1 hour is equal to 60 minutes, and 1 minute equal to 60 seconds. So totally 3600 seconds. Okay, so we change to time 1000, so we change from km to meter, and hour from 1 hour to 3600 seconds. Okay, so the answer is this one. Okay, let's see average speed for speeding up. Actually, it means the accelerations. Okay, they are the same thing. Okay, in part B, what is the average acceleration while slowing down? Actually, it is not accelerate. Okay, it is not accelerations. It should be decelerations. So the train keep in speed of 30 for a while and then slow down to rest. So at the end point, at the finish point is 0 minus 30. Okay, time 1000 over 3600 is the same as this part. We just change unit, but the time here is 8 seconds. Okay, over 8 seconds. So we have negative acceleration, negative 1.04 meter per second square. In today's program, we have learned velocity and accelerations. It is the first episode of mechanics. I think I will film a few more episodes in the near future. Thank you for watching. See you until next time. Bye bye.